This is the breakdown of the mass and change lab. So what was that real kind of takeaway thing from this lab? And what we're looking for is the law of conservation of mass. Now, you guys at the end of class came up with some rules for us to kind of follow to think about the way that the universe works. One thing, if there's a change in mass, matter, our dots, has to come from somewhere or go somewhere. Now think about that. That means that if I have a gain in mass, something has to come from somewhere. If I lose mass, something has to go somewhere. So the law of conservation of mass in its normal form, so if you were to look it up, it would say that matter cannot be created nor destroyed. It can only be altered. So we can't just have things appear from anywhere. We can't just have anything disappear from anywhere. It has to come from somewhere or go somewhere. And then lastly, we should show the same number of dots before and after to tell the whole story. So when we're thinking about our models, the ones that we're creating in class, we have to account for all of the dots before and after. So what does this look like for us? Well, let's look at one of the simple ones that we had. And this was the melting ice. So melting ice, so we had the scale, so here's our scale on the bottom, and we had our beakers on the scales, and we plopped down an ice cube. So let's draw an ice cube. We got 1, 2, 3, 4, 5, 6, 7, 8. Now, what happened when we had it on the little hot plate? If you were very careful and you didn't get any of it to steam or boil or anything like that, and we just got it to gently melt, all that happened was that they spread out. 3, 4, 5, 6, 7, and 8. So we have the same number of dots before and after in our model. So, of course, what this is telling us for our full story is no change in mass. There's the same number of dots. Now, this is the exact same model. So if we think about our other example, let's look at the dissolving sugar. So dissolving sugar, we had the same thing. So we have the same kind of water in the cup. We have some sugar. We mix them together. Nothing left the top of the scale. So this, what we're looking at here, everything on the scale is called a system. And in my system, nothing left and nothing came in. So therefore, I have to have the same mass on both sides. So there was no change in mass. Now, in class, there was a slight change, but it's most likely due to placing the cup down into moisture and picking it back up. So that's going to be more user error than, say, actually perfect. So this is what should happen, where you take the sugar, you dump it in, place it back on the scale. And if you leave everything onto the scale, it should stay exactly the same. Because again, nothing is gaining or losing. Now, if it boiled, or if you remember our dissolving sugar, we had a decrease in our mass. Our mass decreased. So we started with 4 dots for our Alka-Seltzer. We started with 8 dots for our water. And some of it steamed off. So when we put in that, we had that bubbling and that carbon dioxide that's leaving. So some stuff must have left because our mass went down. So it's still accounted for, it's just starting to go away. It's starting to leave our system. So our system, again, being what's on the scale, this is now leaving that system. And then lastly, we had my favorite example, which is the steel wool. So the steel wool, let's actually do this one together. So if you were looking at what we did, so we started with a clump. 1, 2, 3, 4, 5, 6, 7, 8. I'm actually going to do 9 and 10. We're going to do 10. And then I fluffed it out. I moved it away. Right? I pulled them apart. So we still have the same amount. We just now have them in a more spread out fashion. So again, nothing has left. So in this particular piece, no change. And then we burn it. So let's start with our same model. 1, 2, 4, 5, 6, 7, 8, 9, 10. And when we burned it, we actually found something pretty strange. We actually found mass increased. So what is the only explanation? What is the only thing that could have happened? Well, the only thing that could have happened is that some matter is now attached and has been added in. So if we're here, we got 1, 2, 3, and we'll do another 4th one here. And we have new matter that has come in here. Did that matter appear from just anywhere, or was it in the atmosphere around it? And truth be told, it was probably in the atmosphere. So we're going to just draw that as it goes here. So it shows that it's in the atmosphere as it moves toward there. And once it's in and locked into that steel wool, it's going to show us that we have an increase in mass because there's more things attached. There's more things in our system. So that's where that's coming from. So really, our big takeaways, just to make sure, we have the law of conservation of mass. Matter cannot be created nor destroyed. It can only change. So if we have a change in mass, matter has to come from somewhere or go somewhere. Remember, our definition of matter is just stuff. So we should show the same number of dots before and after in our models to tell the whole story. All right, thank you very much. If you have any questions, I'll be available in class.